welcome to this video. In this video, we are going to start the very first chapter of physical chemistry, solid state. So, this chapter will be covered in a series of lectures which will come in parts. So, this will be the very first part, part 1. And likewise, we will have a lot of upcoming parts for each of the chapters of the chemistry. From this video, we are going to start with the very first chapter, solid state. So to start with, here I am sharing with the handwritten notes to help you all with. So the very first thing that we also know and which we have also learned in our basics, that there are three physical states of matter. We have solid, we have liquid, and we have gas. So in this chapter we will be particularly going through the solid and then comparing it with the liquid and gaseous states. So to start with, the basic physical states properties of each of the solid, liquid and gas. Like if you can see here, shape wise we have shapes and volumes. So solid have a definite volume and shape, liquid have a definite but not a definite volume but not definite shape, while gas have neither of all. Similarly, density is very high for solid, liquid is little less than solid, and gas is very less than solid. So the least of all. Then for compressibility, similarly you can see. Then for diffusion, you can see very less rate of diffusion in solid. Liquid has a little bit faster than the solid, and gaseous are really very highly diffusible, like it can diffuse very speedily, rapidly. Then vapor pressure, everything is there. Melting point, the one of the most important points. Melting point is very high in solids, then little less than solid in liquids, and least of all in gas. So these are the very basic property of all the three physical states of matter, which is for solid, liquid and gas, and with this you can differentiate between solid, liquid and gas. Now to move ahead, since the chapter is about the solids, so we will be just describing it about the solids. So what are the solids? So solid, statically defining it, the state of matter which has a definite shape and definite volume are considered as solids. So anything of the matter which has a definite shape and definite volume. Actually you can make it all using all the properties of here which I have been described here in this. You can use all the properties to define solid. So like I have defined it as a definite shape and definite volumes to term it as a solid. Then what are the types of solid we have to read in this chapter? We have two types, crystalline solid and amorphous solid. So to start with, amorphous solid are what? So you can see here, the amorphous solid particles are not arranged regularly, like it has an irregular shape inside the amorphous solid structure. Also it doesn't have any characteristic shape. You can see here there is no characteristic shape for amorphous solid. They are also called as supercooled or pseudo solids. Okay, they are also known as supercooled or pseudo solids. You can see here, and you should keep in mind always this thing. Then to move ahead, what is crystalline solid? So examples are also there in case you want to. Plastics, rubbers and gas are the typical example of amorphous solid. You should note it down. Then to move ahead with the crystalline solid, another type of solid, it is a little bit different type of solid. It has a particular shape, particular geometrical shape. It has a very sharp melting point. It has particles are in amorphous. What we studied that amorphous have no arrangement of particles structure, but in crystalline there is a particular structure of all the constituent particles of the solid. So the basic difference between amorphous and crystalline is that in amorphous there is no particular structure of the particles of this solid, but in crystalline solid there is a particular structure. They are arranged in a particular way, in a particular structure in crystalline solids. Okay, they are also known as true solids, like we regularly use. As examples are ice, gold, copper, iron. These are termed as examples of crystalline solid. So I think these two will be very clear to you, amorphous and crystalline. You should keep in mind the amorphous is also known as supercooled or liquid or pseudo solids, or crystalline solid is also known as true solid. So these are the basic difference between crystalline and amorphous. On basis of various properties, you can also differentiate, like on the first, cooling curve, but it is that amorphous solid has smooth curve in cooling, like they have sharp cooling curve, while in crystalline there is no sharp cooling curve and it can break at any stage. The graph of like this, like somewhere this, then again it will break, then this, okay. But in amorphous solid it will be always like this, okay. So this is the basic difference between the cooling curve of the amorphous and crystalline solid. To move next, there is another property, one of the most important property of this topic, isotropy and anisotropy. Isotropy is what? The substance which show the same property in all direction are said to be isotropic. So this property of showing the same property in all the direction are called isotropic in nature, and anisotropy is just opposite of it. So what is the property of isotropy? Then which the substance which are the solid which are isotropic in nature, they will have very low melting and boiling point, and they are particularly liquid or gas at the room temperature. Okay, so you should just keep it in mind. Next property to compare with is hydrogen bonded molecular solids. So you can again see the differences here. What is hydrogen bonded molecular solid? These are either solids or volatile liquid at room temperature and normal pressure. Okay, so these were the examples of this one. Then what is metallic solid? Metallic solid are all the solids except mercury and gallium. Okay, all the metals are solids except mercury and gallium, which are in a gaseous state actually. So mercury and gallium is not considered a solid, except that every metal that have been found so far is considered as solids, and these are called as metallic solids. Okay, to move next, we will have this topic, crystalline or unit cell. In this we will be covering in upcoming parts also, but to start off, just as an introduction, what is crystalline or unit cell? So unit cell is the very basic, like how in a body you have a shell, then you have a tissue, then you have some structure, then you have some body part, and then finally it all constitute your body. So similarly, for a solid there will be a very small, the smallest constituent particle is known as unit cell. Okay, like for example, I'm just drawing it for an example. Forgive me for any styling. Okay, so this is your shape, just in case. So just suppose this is made from like this, so this will be your one unit cell. Again this will be another unit cell, this will be another unit cell. So these small particles, okay, these are unit cells. Okay, unit cells are like, if you take this is the unit cell, and if you can make, you repeatedly use this, so you can convert it into any shape, right, into any of the structure. So this is the unit cell, that is the smallest constituent particle of any solid, is called unit cell. Okay, and the whole thing, it is called as space lattice. In a 3D, if you will draw this in 3D, it will be called as space lattice. Okay, and any point will be called as lattice site or lattice point. Just keep it in mind. These are not asked particularly in the exam, but you should know it. Then to move again, there are covalent solid. So what are the properties of covalent solid? How you can classify covalent solid? So covalent solid have non-metals. Generally they are non-metals and bonded by covalent bonds. So you will be learning about covalent bond. You must have learned in the 11th class, but you will be learning this in upcoming classes also. Covalent bond. So the basic property are, they are basically, most of the covalent solids are non-metals and they have covalent bond in between them. The network extends throughout the solids and it is also called network solid. They are also known as covalent solids, are also known as network solids. You should also know it. Okay. And how it is defined? It is defined as the arrangement of atoms extend throughout the solids and are called network solids. So it is the arrangement of atoms extend throughout the solid. Then what are the basic properties? They are hard and brittle, they have high melting and boiling point, and they are poor conductor of electric current. So these properties are must. You must keep in mind what are the at least 3 properties you must know about any of the topic you are learning in chemistry, because you never know what is the question you are going to get in the examination. So for the covalent solid, the must thing you will rarely know it as what is the different definition of covalent solid, but you might be asked about what are the properties of covalent solid. So must keep in mind these are the basic properties. They are hard and brittle. They have high melting and boiling point, and they are poor conductor of electric current. Then to move ahead, we have molecular solid. With the name you can specify the solid which have the constituent particles of molecular solid are molecules. So the molecules which make up the into a solid structure, solid space, so which is they are called molecular solid. So the constituent particles of any solid which are molecules we will term as molecular solid. So for example, we have H2, O2, F2. These are molecular solids. Okay. To move ahead, these are joined by weak dispersion force. We will be learning about weak dispersion force again in upcoming lectures. Again, the basic properties of molecular solids. You will be asked sometimes what is the difference between the what is the difference in covalent solid and molecular solid. So then you can write in those properties. Like we just read here that covalent solid have high melting and boiling point, but molecular solid have low melting and boiling point. They are soft, and this was hard and brittle. They are non-conductors of electricity, so this is the common thing. This is a poor conductor, and these are literally non-conductor. They under room temperature they are either gas or solids. So under room temperature they are either gas or solid. Okay. So these are the basic difference between covalent solid and molecular solid. You must keep it in mind by moving ahead. Then again, another type of solid we have to read is polar molecular solid. Okay. The molecular solid in which the constituent particles are molecules and are constituted by polar nature. Okay, so in short, what it is, ki molecular solid, like this is the molecular solid. You know it, right? So in a molecular solid, there is two types of thing can happen. One is non-polar bond and one is polar bond. So non-polar bond and polar bond you might have studied in the previous lectures. I'm not going to detail right now. So the solids which are constituted by non-polar bond, okay, these will be termed as non-polar solid like H2, O2, F2, and the solid which are termed by polar bonds, okay, like HCl, NH3, these will be termed as polar molecular solids. Okay, and again I have just discussed about isotropy a bit above, and this is just opposite, the substance which have directional property, like in different direction it shows a different properties. It is an anisotropy. You must have learned it. You must know it that any solid which have different property in different direction is anisotropy, and just opposite isotropy which have same property in all directions. So amorphous solid are isotropic while crystalline solid are anisotropic. This is the one of the key things that you must keep in mind, that amorphous solid are isotropic and crystalline solid are anisotropic. Then a cleavage property is what? Amorphous solid don't have clean cleavage, whereas crystalline. So clean cleavage, what it means, when you cut the amorphous solid, it will not be cut into very cleanly, like cleanly. You understand cleanly, like cutting of a cake, sometimes cut very clean. But amorphous solid are not that clean cut. Okay, but crystalline will mostly it will cut cleanly. If you will cut crystalline solid, it will mostly it will be get cut in clean parts. The corners of the cut part will be very clean. So you should know it, cleavage property. Then it is bond order. Bond order is amorphous solid have short range order, while crystalline solid have long range order. Okay. Then we are done with the comparison of amorphous and crystalline solid. Now we have classification of crystalline solid. So inside the crystalline solid we have four types: ionic solid, covalent solid, metallic solid, molecular solid. So we will be describing it in upcoming lectures. So till now we will be just visiting through the name of the four parts of crystalline solid: ionic solid, covalent solid, metallic solid, and molecular solid. To sum up in this lecture, what we did, we started with the three different matter types, which is solid, liquid, and gas. Okay, here three different physical states of matter: solid, liquid, gas. We differentiated with the base of properties. Then in solids we came up with two different types of solid: crystalline and amorphous. And then we did amorphous basic definition, Then crystalline, a basic definition that crystalline have very arranged constituent particles inside. Amorphous doesn't have any arrangement of the constituent particles. They have they are also known as super cooled or pseudo liquids, pseudo solids, and in crystalline we have true solids. Then on the basis of various properties we differentiated cooling curve, that amorphous have sharp cooling curve, crystalline have very braked, very cut type cooling curve. In short, no sharp cooling curve. Isotropic, crystalline are anisotropic, amorphous are isotropic. Then metallic solid we discussed with the properties, you must know it. Then crystalline solids of unit cell. Then we gone through the covalent solids, molecular solids. In molecular, two types of molecular, non-polar molecular and polar molecular, with examples. You must keep it with examples in contact. Then cleavage property, bond order property, and to sum up, so basically we just differentiated between the types of solid and covered into the deep what is amorphous, what is crystalline, and the basic properties. I hope you will get an idea how the chapter is going to be. You can leave the comments about the changes or anything you just need to know. I will be putting this notes in the description box, and you can see from there. And just tell me about the video, how you like it, or what is the suggestion from your side. So that's it from my side. Please join me for the next part of this chapter. We will be going and taking. I will assure you that I will take every of your doubts. You can just put it on your comments. I will try to explain in the upcoming series of lecture in all details. That's all. Thank you very much.